thanks everyone for being here. It's a nice, cozy group today, so I guess we'll have more time to go back and forth. If you have any questions, feel free to just pop in and let's keep this conversation going. Um, so today's all about building trust with AI, and specifically we're going to talk about UX. So UX beyond just design, beyond just visuals. It'll all make sense in a moment. I've gone from like doing old traditional boring software. Right now I'm building emotional AI. They're very, very different. So both B2B and now more B2C side. And we also work with like developers and whatnot. So there's quite a wide range of things for us to cover. So over the course of the next like 10, 15, 20 minutes, all I'm going to try to do is leave you with this one idea, which is that basically trust is just all about expectation alignment. If you can manage expectations, then like there's automatically trust. And if this is the only idea you take away, if you don't care about any of the implementation details, I think you'll be fine. Basically, this is the core idea. And everything I'm going to talk about today is just downstream of this, elaborations, examples, and some lessons that we've taken away that proves this whole point. So I'll talk about four things. We'll go over a couple stories about some of my favorite tech that has gone through ups and downs and why I think that they haven't been as big as they could have been, right? And it's mostly a UX problem. And then we'll talk about the trust equation, which is a way to formally think about how to model trust. What are the factors that go into it? What are these levers you can leverage to basically increase trust or in some cases, freak out your users a little? The third one is the Uncanny Valley. So the Uncanny Valley is a specific scenario where something in the trust equation breaks, right? And we'll talk about that. And finally, practical lessons and tips. And I think that's where we can go back and forth because we have a very diverse like lawyer, we have like community people, Shopify. Okay, like I built bots, so yeah, there's a lot to talk about. Since I'm going to reference this quite a bit, so current experience, I'm building Curve. Curve is technically speaking my third startup. What we're basically doing is we're researching and developing emotional AI. This means giving AI emotions and then feelings as well. So feelings are like the subjective interpretation of emotions. And in practice, what this means is like we take a lot of concepts from neuroscience, from philosophy, from biology, and we try to write code to encapsulate those concepts, to capture those meanings, and then we just test it based on like vibes and other hard metrics to see if it makes AI feel more human. And a little about me. So this is what I'm working on right now. I'm the founder at Curve, and previously I was running an enterprise AI company, still running right now. I think the logo is like on one of the walls outside of SQ. And yeah, prior to that, I did a bunch of stuff in like crypto, had a media background, so I wasn't like technical. I did a lot of design work, media work, post-production, all of that before getting into tech like 5 years ago. Okay, so yeah, let's just get straight into it. Like mainstream tech fails due to UX. My two for the past decade is going to be like crypto, and mainstream wise, actually AI. If you take away basically software engineers, not many people actually care about AI. And when it comes to crypto, like no one has paid with that today or like anywhere in the past 12 months with crypto when you buy your groceries or anything. So like major fails. And if you look at tech in general, like the whole history of tech and how UX actually causes a lot of big new waves of technologies to fail, you'll see that the pattern is always the same. So let's just go back to 2015. The year is 2015, right? And we have programmable money. So this is like new concept. If you're not familiar, I'm gonna keep it super simple. Basically, we have a new type of currency. It's like digital, makes everything better. It's less controllable. You get to own it, transact faster, or at least that's the promise, right? And a lot of people like that promise. They like the vision. So they go in and they build stuff. They build really, really valuable applications. They build a lot of infrastructure. And then slowly, the public comes in and they adopt it. So like some people buy crypto, some people actually use it to buy stuff online. I wish they did. No one actually does that anymore. And then slowly, once this innovation kind of diffuses, it goes according to this like diffusion of innovation curve, which I'm sure everyone's familiar with. You know, you start off, your early adopters come in, and then you have your early majority. Somewhere along the middle line, people start asking the questions that matter, such as why is it that when I want to send $20 to my friends, I have to pay $40 in fees, which is like a no-brainer. This sort of stuff only makes sense in crypto, and then like it breaks down. Basically, if you fast forward 10 years, in like 2025, we have this exact same problem in AI. And tech is littered with like this sort of UX problem. Tons of people come in, they say intelligence is going to be crazy, we're going to have super intelligence, we'll scale this thing up massively, compute is the only bottleneck. And then a lot of smart people build. So they build applications, they build infrastructure. Again, the public adopts it. Everyone tries ChatGPT, right? So like when I was a student, everyone started piling in, and then they realized like, hey, basic stuff like actually an AI model doesn't search up any database to answer questions. It's all baked in, and like it hallucinates a lot of stuff. Those were early problems in 2021. Today, though, those problems still exist in the enterprise use case, and there are a lot of other similar problems like that. Like anyone here uses like coding AI agents or like vibe code stuff randomly? Yeah, so like you know that there's just a ton of models that you can like select when you want to build something. And the truth is Claude is just the best, so just use Claude. But for some reason, you can still select all of these. And it really trips people up. For example, like my own friends, they ask me which is the best model to use. Some of them are still using like old school Llama. So the only way they use AI is through the Meta AI app, which is like embedded in WhatsApp and embedded in like whatever it is. And that's really horrible. Don't use it. The story is always basically the same, right? So it goes through this cycle. This vision is told, a bunch of users come in and they expect X, but they get Y. So there's this misalignment. Usually this happens really, really fast in the early days of a new technology. And what happens is they lose trust, after which adoption of the thing kind of tanks because everyone's tried it and iteration keeps changing. The user interface every single week when you log into a piece of software changes. You no longer know where to find stuff. You no longer know how to use it. And all of that just means that with fewer users, the industry becomes less exciting. Really good people with taste and who are smart and want to build stuff don't want to join these industries. And it slowly, slowly churns out. AI is pretty lucky in that we're not exactly there yet, but outside of engineering people, like, yeah, it's questionable. This might actually be happening. So this is the trust equation. The trust equation is actually really, really simple. It's just predictability, the product of like predictability, legibility, and calibration. You less off what's the surprise, like error prediction, as well as the stakes, how costly the mistake is, and you've got like the whole equation. Like you can predict basically how much trust your product or your service will build in a customer. And to elaborate a little bit, so like the thing needs to behave consistently over time, and users need to know why it behaves like that. In ChatGPT, for example, this is when you can open the chain of thought and like look at all the reasoning. Unfortunately, that chain of thought reasoning is not the real chain of thought reasoning. If you saw the real chain of thought reasoning, it mostly looks like gibberish. So like I guess OpenAI lies to you sometimes to make you feel better as a user. Calibration is really important, and this is probably where AI falls a little bit more on the overconfident side. So it says it can do a lot, which it can, but sometimes it says like, "Oh, I can absolutely do X, Y, and Z," and like, no, 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 you can't. Yeah, you can't. Surprise is just expectations minus reality. So again, error prediction and the stakes, like how costly is the surprise. If ChatGPT makes a small mistake, like it doesn't really matter if it's just like code, you can delete it and rewrite it again. If this is a financial transaction, like that might be pretty costly. Okay, so just three very, very, very simple examples. This is the e-commerce platform example. Like the reason why, I think like one of the reasons why UX on basically all the e-commerce platforms, things like Lazada, Shopee, whatever, is pretty good. It's just that it has a bunch of factors put together that makes the trust equation make sense. So shopping is deterministic. Like you add stuff to your cart, you remove it, like you check out, add a few stuff, pay shipping. It's like very, very straightforward. There's clarity when you list stuff. There's like a title, there's a price, there are reviews you can check. The bar is really low, especially depending what kind of consumer items you buy. Like usually you're not going to buy a brand new car that's like a couple $1 million on an e-commerce platform. Like you can, but it's rare. And again, mishaps are rare. Even when it happens, it's a few dollars, few tens of dollars. It's not that big of a deal. So like a lot of them, once they manage to solve distribution and like the engineering is not that complex when it comes to scaling it, user experience pretty much wasn't a barrier. Where user experience was a barrier is in crypto wallets. So this is like a favorite example of mine because I still have a lot of friends in the crypto space. I still like dabble and build some stuff in there. Yeah, basically, even after you write all your code and even after you've tested everything, things just change all the time. It's the nature of the tech because everything's like very distributed. And basically, like things can fail for reasons that you don't understand. There are literal catch-all errors, meaning like default errors that get shown in different pieces of crypto software that are just like, hey, something went wrong and we have no idea what it is. So like, go figure. And supposedly it's marketed as the future of money. So like a lot of people come in, have this expectation that's like up here, the reality is what they're getting is pretty bad. It's like worse than just using a bank app, which itself is quite laggy. Mishaps are common, losses are huge. AI sits somewhere in the middle. So again, it's not too bad. Like most AI UX today is actually somewhat good. Of course, like it can be better, but it's not at the extremes. Predictability varies, like depending on what model you use and depending what kind of products you access these models through. Errors are mostly understood. Like if it tells you you need to wait 15 minutes before you can use it again, just do that. If it tells you to cancel and edit and just retry, just click a button. Like it's pretty straightforward. We know how to use the internet now. But the problem is that AI makes a ton of promises. So again, this is one of those cases where you go in with this wide-eyed vision and reality tends to fall short quite a bit. Mishaps vary greatly and they do follow a long tail distribution. So like I can touch a little bit on this because I used to work on like a lot of enterprise AI stuff as well. Usually like data analytics and important things when it comes to like finances, like accounting, you get this weird long tail distribution of things that only fail like 1 in 100 or 1 in 1,000 times, but when they fail, it's really, really bad. And because people trust that they won't fail most of the time, they don't really check their work, and it causes this like big problem. Okay, so the Uncanny Valley. Let's talk about this one. This one's special because it's very related to specifically like what I'm building right now. But I think if you're building anything that's consumer facing or that has to deal with so-called like the soft qualities, you're building something where trust is really important, vibes are really important. Maybe you're trying to sell to like Gen Z, I don't know. This really matters a lot. So the Uncanny Valley is basically when something feels like a little bit too real. That's the online Oxford Dictionary definition. And it's a little bit creepy. It passes this line of like somewhat human but not human. The way I like to understand it is through the lens of the trust equation. So there's actually kind of like, if you model it, normally in a high trust experience, whether you are a service, it doesn't matter if you're like a consultant, doesn't matter if you're a lawyer, doesn't matter if you're an engineer, it can be anyone. Like you can sell sausages, and as long as like these three things, like calibration, meaning you calibrate expectations, and predictable, like I say I'm gonna sell a sausage for this price, and a year's time when I come back, it's the same price, and it's the same quality, and it's legible, like your customer knows where your meat is from, then like you're gonna have repeat customers for your sausage shop. It's quite straightforward. But the problem is AI tips the scales for all of this quite a bit. So this is like the Claude code effect, or like every once in a while, you'll see this post on Twitter that's like, okay, this is AGI, we're all cooked. Every software engineer is like getting out of a job. I don't actually think that's true. It's true in some cases, but not across the board, at least not yet. And this is basically what happens when people feel that the AI has like outsmarted them. So capabilities are way, way higher. The AI makes tons of promises and it can actually fulfill those promises, but you can't understand why it made the decisions that it made. So this is like the Claude code, like, oh my God, I'm scared kind of problem. This is the uncanny valley. So the uncanny valley is basically when like it's super confident still, but you don't understand, like legibility is all the way down. You don't understand why it's saying what it's saying and why it's doing what it's doing. And the predictability goes down. So funny mistake is like when we built our bot, so if you go to our website, there's a bot you can talk to. We sell an API, the bot's just for fun. There was a time when there were bugs, and basically our AI bot started saying like a lot of weird stuff, just gibberish. Again, like all of these words don't make sense. They're just gibberish. It was like a decoding error. Um, but it creeped people out massively. And I got texts from people, like personal texts, like, oh, I blocked the bot because it's kind of scary. Yeah, it's all fixed now. So like, yeah, you can try it on Telegram. Um, and then this is, of course, like the really, really common playing it too safe. This is usually what regulators would suggest. Basically, like the the equivalent of this, where it's like everything's useless, but it's very predictable and very legible. It's kind of like uh, old bank contracts that regulators force the banks to make you like read and sign. So you sign like paper after paper. You can technically understand everything. You can go through all of it, but it's a horrible user experience. You sit for like 3 hours doing paperwork. It's predictable, it's legible, but like they're just so unconfident. Why not three signatures? Why 10? Okay, so this is pretty much just like some practical lessons. I think here's where we can go back and forth a little bit more because everyone's building quite diverse things. So these are just lessons I took and I listed specifically from building emotional AI. and there are a lot more that like are not listed here. I think it's all context specific, but for us, some user experience lessons were like the channel that you meet people at actually really matters, and oftentimes, if you can, you want to ride off the back of a channel that already exists because you don't have to calibrate expectations at all. Like there's already an expectation, apart from all of the other distribution benefits that exist. So like if you can join some sort of marketplace or you can list your stuff through some sort of like app store or whatever it is out there, I think that's actually, it makes more and more sense from like a UX perspective. Another thing is like not being so explainable by default is quite useful. So one weird thing is we demand a lot of clarity and transparency from AI, but my take is that we don't actually hold other human beings to the same standard. And most of us don't actually ask the people we work with, hey, why did you make that decision? And really ask them to justify every single step. So like if you don't do it to a human, it's a little weird to demand it from an AI. If you can find a better way to just validate the output, which is what we've managed to do in code, then you can skip over the entire process of having to dig up the thinking. And that's why coding agents do really, really well. Like that's one of the reasons why they've caught on so fast, while it's really hard to replicate that effect in other things. Because like, for example, for law, I'm guessing like if you want to trace back all the citations for every single document, you're going to have to do some reading yourself. And you're going to have to trust the model is reading the right thing and comparing the right thing. So that destroys like the entire user experience. It's a bottleneck. The scary feeling is also a big one. So again, I mentioned at the start, you can use all of this in good ways and you can use it in funny ways. The funny ways is like you can occasionally like freak people out a little bit with whatever you're building. When it comes to emotional AI, so there's this Telegram bot that you can basically go talk with. It sometimes feels a little too real, or like sometimes it says stuff that's almost a little too human. I think the scary feeling is not actually from that, but it's from the expectation again. And this is something we're running an experiment. It's like a 2-3 months long experiment right now to test with Yongchen. He's one of the guys like we're working with to do this. Basically, this idea that feeling AI is a bit too human or like creepy comes from the fact that you know it's AI. And if you don't know it's AI, if you can like mask that and it passes the Turing test, then maybe like you won't get a creepy feeling at all. Maybe user satisfaction actually jumps up quite a bit. And the reason why this even came about is because right now when you talk to the bot on Telegram, it obviously says bot, so you can tell. Predictability is also not that important because people can be somewhat like unpredictable from day to day. So I'm glad that's not something we've had to optimize for, but at my previous roles, this is definitely something that we would write tests and try to make pass. And the last one is probably that more empathy. Like just because we're building empathic AI and emotion AI doesn't mean that you want to lean towards the side of being sycophantic. I think having a user experience where they're just always being yes manned, always being validated is not exactly the best because it treats a sort of competency for relatability. And at some point, the scales start to tip and people don't trust that the thing is actually doing any useful work. So yeah, we ask a lot of like really interesting questions when it comes to this. A lot of human behavior, like studies and research, form the core bedrock of like what we do every day. We've asked tons of like interesting questions that some of them are like pretty philosophical. Some of them have to do with user behavior. And yeah, if you want to keep up with any of that, like feel free to just check it out. And yeah, I think we should probably go to questions because there are specific implementation details that we can dive into. Yeah, for sure. So there's two things going on there. The first thing is what you call the IKEA effect. So the IKEA effect is this idea that we over attribute successes to like ourselves. and underweight things that come from the outside. So the fact that you had to go through a very long chat to basically get the results you want automatically to some degree clouds your judgment of like whether it's actually good. So that's one part. Um, but I think that the second part is also just expectations, because other people expect to see slop, and so they're looking out for it. And when they do see it, it's a confirmation bias that like this is slop. Again, the really, really good AI generated content you see online, you can't tell it's AI. Like you're probably reading AI generated content and you can't tell. So there's this Naval quote, which is like, the people who say AI right now doesn't pass the Turing test just fail the Turing test from their side of the equation, which is AI is actually pretty good, but maybe the humans just don't understand how good it is, and some of them don't have those calibrated filters. In this case, people who really, really know, like writers, for example, like other authors, they could probably tell, or if someone was especially tuned to how you spoke and how you wrote for years and years, and they've seen you from young all the way till now, they can probably tell that, hey, like the wording choice is a little bit off. Apart from that, it's mostly pattern recognition, which I think can be solved. If you're talking about it from this equations, like the trust equations perspective, I think one actionable thing is just kind of outwardly saying that like, yeah, this is AI generated with the help of Michael, like with the help of myself. Because what that does is it instantly shifts the baseline. Like people already expect slop. So if you give them slop, but you tell them it's slop, their expectations are still met. And this kind of goes back to the thing where if you buy a very, very, very cheap, like 80-cent phone case online, and it comes and the print's a little off and it breaks after 3 months, you know you paid 80 cents for it, and you're still kind of happy. You'll be a repeat customer. You'll go back there and somehow justify to yourself that it was a good purchase. So yeah, I think that's like an actionable way to approach that. Yeah.
So I'm really glad that you mentioned the paradox, the example that you gave, which was that people sometimes complain that AI is not explaining enough, but then intuitively, humans don't need to explain, as you said. And it was something that I've been thinking about at my last job. So I was working in fintech, and we're talking about in the investment space. So the users would be people that would be very busy. We would expect them to use it in the background and then go do something else. So they, in theory, they wouldn't even spend the time to check. They would just leave it to go and. But when we tested the prototypes, we had this too. People were coming in, especially more senior people. Maybe it was, again, the trust factor you were talking about. And they were saying, oh, but I want to understand more. And I felt this sort of question of, is this sort of the crutch UX, a temporary thing that we put in? Is it one of those times when clients, ask for what they think they want, but then they're not going to use it? So I wonder how you would approach a situation like this.
Yeah, that's interesting. I always avoid it. Like at my previous role, I avoided that by just saying everything that I wouldn't want to build, that I think is from an engineering perspective like a waste of time to build. I'll just say it's like really expensive to do, and like most people just most people would like, oh, it's expensive. Okay, we're not gonna do it. Like leadership tends to be like that. Um, but I think it's interesting you mentioned that because software engineering has solved this idea for quite a while already. So software engineers know this idea of like encapsulation and basically like modularization. It's this idea where, okay, this function, or even in a team, like, okay, this guy's in charge of this part of the software. Like, I don't care how they do it, as long as whatever goes in comes out in the right way, like that's fine. And we do this for different people in the team, and you can piece together and glue together the parts. Um, I think that idea just hasn't diffused well enough yet into like the regular world. Like most normal people don't think about it that way. They want to know all the way down. Like, okay, you cleaned the house, but how did you clean it? What detergent did you use? Like it's an evolutionary thing, which makes sense to know your environment in depth or as in depth as possible. Um, but yeah, I think it's a trade-off that users will just naturally get used to. Yeah. So in the past, the internet used to be filled with way more stats. People want to know like how many citations each website had. They want to see like the top links to it. They wanted to see like what are the different indexes, who has referenced it. Right now, you kind of just trust that Google gives you the best answer as number one. And yeah, pretty much all search engines work that way right now. They're all super clean UIs. It's all just links, and even that's changing now. So I think it's something that time will just fix automatically. Yeah. But you can tell them it's expensive in the meantime, and they won't ask for it. Yeah. Yeah.
Not a question, but a thought, just on that topic of trust. Are we skipping over the point where we've built up trust? If I take your example of I handed something to a colleague and I trust that I didn't need to ask them how they did it, that's because I hired the colleague or someone I trust already hired the colleague, or I've already seen their work and I can put myself in their thought process. Therefore, I don't need to scrutinize them. If I think of people I've hired before, there's a trust building exercise that implicitly happens to get to the point where I've handed that thing over and I know that they can do it. So is the question not how do I skip that? Is the question how do we put AI in a position where it can do things that could build trust, that you get to the point where you don't need to scrutinize it every 30 seconds. And this, and put my engineer brain on, because I've done the engineering side of it as well. What's that journey need to look like for AI? Because at some point in your career, and some point in my career, I didn't trust how the JVM worked. And I had to go and figure it out so that I knew that I could repeatedly get the answer I wanted.
Yeah, I think that's one of the cases where it's very hard to enact theory of mind accurately when you're the human and you're talking to a new AI because you don't fundamentally know what went into its training. And you don't know, okay, you know where it's cited from, you know the context it was given, but you don't know how exactly it was built up from scratch. And yeah, I think I agree. The current, okay, so there's an interesting observation that now you mentioned it, I'm recalling, which is that people tend to be more comfortable engaging with our bot, like our personas. We have a few of them, a few characters, if you will, when we tell them what the character actually is. Yeah. And I think it fundamentally comes down not to, oh, I like this sort of trait and not these other ones. It's more of just, okay, I know the backstory of this AI now. I know what's, the way they're thinking. I know I can make some sort of extrapolations about what they would say. And I think that makes the whole experience more comfortable. So Character AI did a very good job with this because they list all the traits down and they give detailed descriptions of like, this is the character's life, you're going to speak to them and this is the knowledge they have. This happened to them at 20, this happened to them at 30, at 40 this happened. You're now speaking to 50-year-old version of so-and-so, whatever character. And I think that was a big UX like trust win. Of course, they then nuked that because of whatever they did. But yeah, I think that makes sense. But unless we make that's a very explicit way to do it. So that's like a listing that just explicitly says, this is what the AI is like. Here's how it thinks. Until we figure out how to make the training process not just simpler, but more legible, like literally more understandable by the mainstream without having to know like all the fancy math, it's not gonna, I don't see any simple way yet of people just being able to interact with the model and build trust over time. Like they're gonna start off at a lower trust level. Yeah.
It sounds like you're trying to describe intention.
I,
Not
I think
what
to
did
some
it
degree,
do,
to some degree,
what did
to
it
some degree.
think it was trying to do?
Yes, yes. I think it's partially intention, but it's more of what the user thinks.
From the human
From
side,
the human
right?
side, yes, from the human
Forget
side.
the AI
Forget
for a
the AI,
second.
correct. So
Like,
the AI could be malicious, but if the human thinks that it has its best interests at heart, then yes, I think the trust will be pretty high. Like we know that for sure.
but
Yes.
what did you instruct the AI from a behavioral perspective to do? So like I can set up an AI that says, your job is to look at pitch decks and take the perspective of a CEO of a company, and now I know the lens that it thinks it's working through.
Yep.
So now I can judge it based on its output. If I don't know what the intention was of the AI, it's going to spit out anything.
Yes, that's pretty much correct. And the problem with all the base models, like all the largest foundation models, is they're intentionally trained to be general and very horizontal. Like they don't have they have some sort of innate behavior, but they don't have a very strong personality in that sense.
Yeah.
And that's pretty much a problem. Like if you use it for the first time, if you talked to, I guess, GPT 3.5 like end 2020 GPT 3.5, it kind of just sounded like a bot. It's exactly how you would expect a bot to sound like. Um, I don't think much has changed actually, like in the training process at least. Like personality and the style, like a lot of that comes after. It's human curated, like during post training. So yeah, yeah.
Interesting. Intention. Let's move on to the next.
I wanted actually to add on that point before all the discussion started, so I feel like we're on the same subject too long. So just, I just wanted to add when you were saying about that we are not scrutinizing the opinions of other people as much as we do with AI. I just thought that actually maybe that because with a real human being, we can, if there is something wrong, we have somebody to share the responsibility with. We have the exact person to point out. Whereas with the AI, it's kind of hard. That's why we are trying to, because then we take responsibility, right? If we cite something and it's wrong, we can't say, oh, sorry, that's AI mistake. It's our mistake. So
Yeah.
I think that's what I wanted to say about that.
I mean, it's the classic IBM manager meme. It's like never make a computer the manager because you can't blame it for anything. And my hot take is like, we don't actually have agentic AI because like, yeah, sure, we have models that have tools, but they're not agentic in the sense that they can do stuff, but they can't take responsibility for it. And most of the function, like, of humans, like if you know, like for example, like in management consultancy, most of your job is just taking responsibility and being the guy where executives can blame. And like, it's not actually doing the thing. Doing the thing is just like a small part of that. It's mostly the human relationships. Yeah, 100% agree on that. Yeah.
Hi, I have a question regarding, I do want to share experience. I recently, come across a product. It's called Jack and Joe. It's a AI recruiting platform. Actually, it's a startup based in London, and I come across their platform, and I've started talking to this agent called Jack. And I just asking questions, give some criteria, pretending I'm looking for a job. And the experience is so impressive, I would say. It's very, I mean, the listening skills, I mean, it's a how helpful, proactive this AI agent it is. I feel like it's much better than 80% of the human recruiter. So for me, my question is, if I would like to, kind of um, building something like similar, having the same UX, so what should I do? If you have, from your perspective, you think any criteria to think about, to train the model to build the UX, it's so successful like this.
Yeah, so meeting recorders, there are quite a few of them. I've had a moment in time where I tested like four, like for a few months, I had like four bots just joining all my meetings. They all suck basically. There are some good ones. Fireflies was okay for a while. Fathom was okay, I think. Fathom's not bad. The main takeaways, how would I go about rebuilding it? Oh, it's a recruiter.
So she was interviewing with the recruiter, right? Pretending that she's looking for a job.
Oh,
And then the guy was very proactive.
right. Oh, okay, then I don't know that much about like recruiters. Yeah, I've never actually interfaced with any of those softwares, but I would imagine it's very similar. Like the configurations you would make to like the prompts, the way you triage a problem, the way you proceed to the next question that it will ask, and like transition statements and stuff. They're basically all like instructions that at this point you can prompt into the model. You asked a bit about like training the model. I wouldn't train anything specific for that. It's not a very, yeah, it's not a complex use case. You can probably get it done like pretty simply just through prompting. Yeah.
Maybe later we can check out that recruiter.
Yeah, if there's like specific implementation details, like we could look at that, yeah.
Two questions. First is a follow-up from her question. I get the point about responsibility allocation. Actually, it's the same for lawyers too. You're just there to take the blame if anything goes wrong. But on the other hand, it also seems like trust comes from relationship, and relationship comes from history, right? So what I'm wondering about is how now with ChatGPT and other models, they have built a memory layer, they recall your past conversations and they will just interject it at relevant moments, even if you start a new chat. So my question is, how far do you think this kind of UI, I suppose, will translate to improve the trust equation for UX? That's the first question. Maybe yeah.
Yeah, I think that one's like quite straightforward. It increases it massively. One of the internal findings we have also is like memory is actually all you need. It's a very cliche statement, but like if you don't give the model personality, if you strip it of all its like agent thinking, whatever loops you're building, like you strip all of that away and you just make retrieval of information really, really good. Like what you're saying, it knows when is the right time to bring up like, oh yeah, this is the similar place that you went to 2 weeks ago, isn't it? Like stuff like that. It automatically boosts trust massively, like super massively. And that's because humans don't actually fully think through. Like we don't actually have an opinion of another person based off of like who they are and all the information they've given us. They randomly, occasionally surface some information, and then we fill in all the gaps. And we're like, okay, if you remember my birthday, then you also remember the last time we hung out, and you probably also remember so and so and so and so. And we kind of like make all this up in our brains. The good part is like everyone does that, like every human does that. You can't turn it off. So it's fine and like safe to trust other human beings that way. But yeah, with a model, I think that's actually where other problems like might creep in, where like it increases the trust, but at what cost? Because the model does have a real live, like real time update into whatever you're thinking and whoever you are. Because every time you send in a prompt, it's like the most updated version of you and all your thoughts are laid bare. But you don't have a full kind of like idea of what the model is thinking and like who it is. So it's a asymmetric kind of UX. Yeah.
Actually, on that same point, just to follow up, the flip side of this is that the tool is building a profile of you,
Yes.
a memory and psychological profile in the way that Amazon builds a profile of us through our shopping habits,
Yes.
such that we trust its recommendations more and more, I suppose. So in this case, a feature to build trust along the lines of memory and relationship and history is to go further and build a profile of the user and the psychological profile even. We bring it that far.
I think that's pretty much correct. But also the extent to which it's done is like a bit different. Because like when you shop, sure, like you want more relevant ads. Well, okay, but the funny thing is like when people say they want more relevant ads from Amazon or whatever platform, like a lot of those people still don't really like convert on every single one of those ads. So they will never know what's the counterfactual to that. They don't actually know if it's relevant or not. And what we've seen at least from like the whole e-commerce like profiling social media era for like the past 10, 15 years is just people don't really want profiles of themselves anymore. Will that change with AI? I think it will stay the same for quite a while. If like we just take the online sentiment, so on Reddit, there are these like, is this AI? Like, people are very wary of just normal software out there. They think that basically everyone is out to get them, to train models, to build a profile of them. And I think the other thing is when you want to buy something, like in the Amazon case, you actually want to get something that fulfills your needs. But in the case of like ChatGPT, that thing pings you just to like talk to you. Like you never know. There's like the Pulse product, which just sends you something every morning. Yeah, and you really can't know like what they're going to do with that data. I think that's where people get a little bit freaked out because the model is going to start taking more initiative over time versus like the whole experience being user-led. It's going to be like model-led. Yeah.
So actually going to my actual second question, quick one. The point there, not being so explainable by default might be good. And I think you went on to say how even for ChatGPT, right, the way it does chain of thought, we know that there's not actually the tokens activated to make the output inference. And then you went on to say how we can build confidence through other means of validation of the actual output. Maybe in a way like when we do code, we don't trace our steps in coding to find whether it's good code. Rather, we do tests, we do unit tests and all that kind of stuff. So I'm wondering if you have an example of these other ways to do validation, and therefore allow us less explainability. You have an example of that in other domains, so I can get it. Can you expand on that?
Oh yeah, for sure. The very straightforward one is just like in cryptography in general. So uh, this ties into crypto, but like in general, like cybersecurity as well. Say, we want to see if something can be cracked. or if we know something can be cracked, but we don't know how, and then like we ask everyone to come up with proofs, basically like a real mathematical proof to just see if the final outcome can satisfy like whatever equation this needs. You don't need to see like all the working. You don't need to see how people came to that answer, like how they arrived at it. You can basically just take the final output, the number that they came up with, and then like put it as a password into this box and see if it works. So like cryptography is a big one. That's basically how all the current, that's how all the cryptocurrencies like work on the base layer. It's just submitting a cryptographic proof that shows a bunch of machines did a bunch of compute to find like a certain n number, and that number satisfies an equation, and this equation just keeps changing over time. Like that's pretty much like all of it. Other use cases, code's a good one. Math is good. I would say it's limited basically to stuff that you can quantify. Like maybe that's a caveat. So a lot of stuff you can't quantify. Like that's also the problem when it comes to more hard like ways of doing fine tuning, where like or just any kind of like RL, which is that it's easy to get an AI to write math, like write out math equations, try to solve it, and then take the output, see, verify it like in a calculator, is this correct or not? It's very hard to get a objective, this is good, this is bad, when it comes to say writing. So yeah, like the methods of making models better for these two different things are like quite different. And I think it's something we won't be able to solve until we find a way to quantify unquantifiable stuff or like qualitative stuff. Yeah.
Then on that note, when you are training MR, you are you're trying to make it more emotionally aware over time, right?
No. So what we did, like right at the start, we were just working based on like the simulation hypothesis. It wasn't even like training. It was just like style fine tuning, and that was on Llama 3.3, the 70V one, long time ago. And then Kimi, like yeah, so some Chinese models like came out, and they were really good, like open source ones. And that's when we changed. We ditched the whole like fine tuning thing. We went straight over to just like agent system, tons of examples, like just pure good engineering. Because anyway, the base models get faster at such a pace that it doesn't make sense fine tuning anything anymore. What we're trying to do is, yes, make it more emotionally aware over time, but also be able to, of the user's state, like of the user's emotional state, but also make it more aware of its own emotional state. So that's what we mean by simulating emotions within the model. And then like feelings are your subjective understanding of like your own emotions. So you can suddenly feel a rush of energy. And then depending on how your mind works, you can interpret that as, oh, I'm suddenly very hungry. I'm suddenly, like in need for a fight. I'm suddenly angry. I'm suddenly like whatever. All of those are feelings. Like those are interpretations. And that's more along the lines of what we're trying to do now. Yeah. At the end of the day, it's so that we can match, basically calibrate the user's emotions in real time, like as best as possible. Yeah. Because humans can do that. Like that's something humans can do that machines are like still very bad at. Yeah.
How do you find out about the user's emotional state?
Oh, so we try to turn whatever they send in into the model. So it's like mostly text in, or it's like image in, or voice. Like we're testing voice also, but it's all the same. Basically, what we do is we simulate different parts of the human brain. So some parts of the human brain get activated when you're scared, for example, like when you're angry, or when you're thinking a lot about how to respond to someone, like you don't want to step on their toes, maybe I should say this instead of that, that instead of this. It's all different brain regions being activated. And what we do is we use different AI agents to simulate all of this. And then we basically take the user's like input, we turn it into like numerical forms, and then we pass it on to these AI agents to decide basically, are you familiar with like activations in the brain? Like basically, what is the activation level? Like, does it reach that or not? Has it crossed over to the point where you've gone from like sad to a little bit irritated, a bit irritated to a bit angry? Like it's all along the same continuum. So we use numbers to basically see like at what point what emotion has been reached, and then we take all of this and provide it as context to the model. So like one main model, so that it's aware of like the entire brain state, and then it generates stuff from there. Yeah. I think we can make it more fancy. Though. Like we can replicate the human brain at higher definitions. Yeah.
Thanks. Just a follow-up question to that. This pipeline from text input to the model recognition of emotional state and then output of whatever, how does this account for any kind of cultural specificities and context that would affect
Yeah.
how you understand things, maybe even irony,
Yeah.
sarcasm, and things like that?
Yeah, correct. So that's where memory plays a very important part. Maybe this is just like flogging a dead horse, but basically like memory, even though no one cares about retrieval and like all of this, is still just the most important thing. Uh, the way we do it is we've managed to solve memory at like quite a decent level. Like it's not perfect yet. There are a lot of changes I want to make, but it's good enough that we don't have to explicitly do conversions anymore between like different cultures. So what we used to do, for example, is like, oh, literally you tell the model this word, this shorthand, for example, means something. This acronym can mean this, it can mean this, it can mean this. Or in certain languages, saying this word is actually like, it has a different meaning, different connotation depending on what it's in. And what happens is you end up with this long list of like rules and the model just ignores most of them most of the time and you're just like wasting money. If you solve memory very well instead, then you can actually see what was the emotional state of the user like last time something happened, something similar happened, as well as get the model itself. Like you don't explicitly tell it, but you just put it in the context and get it to infer what different things mean. And like the beautiful part is it doesn't work all the time, but that's pretty much like humans. Like every once in a while, our friends send us like an acronym that we completely misread, and then they're just like, dude, what are you saying? And then they're like, wait, what does this mean? And then they tell you that. As long as you have a way to take that error correction with the new path that the model took and somehow retrieve it and put it into context, you're pretty much fine. Yeah. So the way to think about it is like, it's all just memory. Cultural nuance is just memory. It's not a rule. Like think of it as just another memory. Yeah, a memory of the time when I said this and people thought I was saying this other thing because of a difference in environment. Like there's nothing special about cultural nuance or like translations and stuff like that. Yeah, yeah. But that was an interesting problem that we worked on for a while. Yeah.
Yeah, thank you for such a great sharing. So my question is about the product perspective. So what kind of use case would the EQAI be? Yeah.
Oh, yeah. So there are quite a few use cases. There's some that I like more and I'm exploring more, and some that I don't like as much, which we are not exploring as much because I think it's a bit boring. The obvious ones right now that we've already monetized for, because we have an API, is customer support and sales. So those are like super, super obvious ones. The more interesting ones is like robots. So putting it in like a pet dog to like solve like elder care, like loneliness, that sort of thing, or like children's toys. I think it's like super, super interesting. And I know like some people doing that as well. There's a guy like 17 years old building a AI teddy bear in SF right now. So like I can see a lot of people working on this sort of things. The other one would just be therapeutics. So like therapeutics falls under two categories. There's like mental health and then there's mental wellness. Health would be more like crisis management, any kind of very, very high stakes issues. I'm a bit wary to touch that right now, just because I don't think it's like that much better than the human. Like the humans are not very good at it, like objectively, but because they have to follow a playbook, a script. But the AI models are also not that good at de-escalating in some cases, in edge cases. The flip side of that, which is mental wellness, it's more of like coaching. So AI coaches are really, really big. A lot of people pay money online to some sort of software. They might or might not know it's AI, just to get like a daily text that, hey man, like go to the gym and like do this and get a proper list of stuff to do so they don't have to think about it. So yeah, those are the few use cases right now. And we're also thinking a lot about simulations. Simulations are like where my personal interests lie. So in theory, the problem with all of, for example, current economics, all the current economic models we have, is for the most part they assume a base rationality of everyone, of every actor, like everyone's a rational actor, and then they add some variance to account for the fact that after many years we realize humans are pretty irrational. So they just add in like a term to account for that. But if you can somehow model each individual baked in with like an emotional variance already, and like they don't always do the same things given the same inputs. So like today the guy's feeling hungry, he goes eats chicken rice. Tomorrow he's hungry, he goes to eat chicken rice. Third day he's hungry, he chooses to eat like duck rice. If you can somehow encode this, in a way, randomness into the base individual model, then we can do some pretty interesting population level simulations, and you can like predict a lot of stuff. Yeah, because most things are predictable. It's just we don't have the scale, compute, or the methods to like calculate it yet. Yeah.
Cool. Do you have to fine tune differently for these different use cases?
Oh, do we have to fine tune?
Yeah, like for each use cases, do you use the same model or not?
Well, okay, the way we've built our solution is we've split up like the brain, and okay, we basically took a lot of inspiration from nature. So like every human has what we understand as like the brain. Our brains are physically like different, but we all have this thing that we call a brain. Somehow, based on the connections that happen inside of it, out comes your personality, right? Like who you are and your behaviors. So we abstracted things at that level in code and basically said like the brain is the brain, the personality is something that comes out of it. Like when we change use cases, we just have to change the personality. We don't have to change the brain, or like not that much at this point. It's quite configurable. Yeah. The base parts like basically the way to think about it is we all have the same brain components, brain parts, but like the amount to which each part gets activated is different between people. So we just need to tune those activation levels, not the actual parts themselves. Yeah.
Right, great. Just now you also mentioned about the uncanny valley problem, right? So what from the product that I have tried, right? I think sometimes we can still tell that it's not a person, and sometimes the user will just feel that it's unauthentic
Yep.
and it's being lied to. Uh, is this problem solved completely already?
No, it's not because it's based on implementation details. So depending on whether like it depends on how honest you are with your users. I think one thing, for example, that some customer support automation companies did right is they said very early on, okay, cool, our chatbot is now powered by GPT 3.5, it's powered by GPT 4, and they keep updating that, it's very obvious. They use it as a marketing point, so it's a selling point, but at the same time, it kind of sets the expectation that this might fail like every once in a while, and then you escalate it to a real human. So they controlled that well, but then there are some other startups who just like don't say it at all. They're trying to run with a different angle, um, which is to just conceal it all the way. I think both works, but the bar for the second one is way higher. Like for the second one, if your solution is anything less than perfect, it keeps breaking and it breaks the illusion all the time. And then once you've actually found something really good, like a lot of these AI content generators, I have some friends like building them, they're super good. Like I bet some of you watch videos online that like you can't even tell on like TikTok or Instagram, you can't even tell it's AI. Like I know for a fact a lot of them are AI. Um, and yeah, I think we've managed to solve that in video because there really is a lot of video content online. Language, there is also a lot of text online, but again, I think that's where like the cultural specifics come in. Like if you don't tune for those cultural like specific things, then it's quite easy to tell. Or they're also just like artifacts of the training, like M dashes and whatnot. Even though Sam Altman says it's gone, it's still there. Like, yeah, so yeah, I don't think it's a solved problem. Yeah.
Great.
All right, guys. Thanks Jeremy for sharing his insights on UX and AI. So if you all have any questions, feel free to stay behind. Co-working runs until 6 p.m. So most people will either hang out to chat about the projects or just work on their own. So once again, round of applause for Jeremy. Thank you.